So let's go over here and first address this problem where we kind of would like to use the wizard specialization, the wizard class, as any other fighter in our game. And the commonality that we need for any kind of fighter is, of course, that it is a creature, right? And we just saw that we can use inheritance up here, like so, and say this wizard is a creature. Now, this is a little annoying. It says we don't really know what creature is. And the problem is creature is defined after the wizard class. So there's two possible fixes here. One fix could do this and just change the order. Put the base class first. The other fix would be to possibly put the creature in its own module, a wizard in its own module, and then they could just import them in the order they need. Now notice down here, there's some extreme duplication. In the init for the creature, we have a name and a level, and we're storing those. In the wizard, we have a name and a level, and we're storing those as well. This is not good, first of all, but there's two ways we can fix it. One way, we could just say, we're gonna have this init method here. We could say super, and this will give us access to the direct methods on creature. We could say dunder init, and we could say name and level. And now the warning will go away, right? And we're actually passing this off. So when you call this method by creating a wizard, you're really just setting up the wizard's properties by delegating or pushing this onward to this method. That's totally good. If we were doing additional stuff, like more wizard stuff here, with the proper spelling, that would be cool. We would totally do this. But if all we're going to do is just delegate up the inheritance hierarchy there's no real reason to even have this method. So we don't even have to write an init method, and we can just inherit this one, if you will. So now let's try to run our game and see if it will work. Okay, a tiger of level 12 appears. Let's just look around until we see the wizard again. Okay, wow, that was a lot of tigers in a row. So the evil wizard appears, and we're going to try to attack it. Remember, when we tried to get its defensive roll before, it didn't have one. Boom. Now it rolled 4,000 in its defensive roll. Yikes, we were defeated. No surprise there. But by making the wizard class derive from the creature class, we now can treat the wizard as any other player in the game, not just the hero. In fact, we can go over here and fix this up again. So here we say creature get defensive roll. And now, because the wizard itself is a creature, we can say self.get defensive roll as well. And the game should play exactly the same. Perfect. So our wizards can now be creatures. Let's work on small animal. So let's define another class over here in the actors. And again, make some space for a minute. So we'll say class. And remember, you just define a class by saying class name, cap words, and then again, we want this small animal to be a special type of creature. And we could just say pass. And if that's all we do, this stuff will start working. Okay, we'll have a toad and a bat. Of course, one minor problem. Remember at the top, the way we imported the actors, we now also need to import the small animal from here. Okay, now we should be able to treat these. Let's run away from that. A toad of level 1. This is a small animal, and perfect. It behaves just like a creature, but there's not a lot going on with this small animal yet, right? There's nothing special about it. It literally just does everything a creature does, other than it does have its own type. And so when we say, what type of object is this in memory, we know that it is a small animal. You can actually ask, is this a type that is derived from a small animal, or is it just a plain creature? We could use that for something, but we don't really in this game. I guess the thing we can do to make the small animal special is maybe it's a little extra weak. So down here, we can change this get defensive roll. In the creature class, it has a get defensive roll, and it just does this. Let me copy the whole thing. And we can actually change how this works. Okay, so we can come over here and say the small animal has all the behaviors and everything from the creature, except it's going to have its own version of get defensive roll. Now, some programming languages, when you're doing inheritance, you have to have special words like override or virtual or these sorts of things. Python doesn't have that. We just have one method. It's called get defensive roll. If we just say it in the other class, it simply replaces it. If we leave it this way, things should just still work again, other than the wizard is not what we're looking for. But the bat is. Perfect. But let's say we want to change this. Let's say we're going to come over here and say, we'll call this base roll equals that. And then we want to return base roll maybe divided by 2. Okay, so it's a really small creature. It's really weak. So we could do this. Let's look around until we find something. Okay, there's a bat, and the bat rolls 3.0. Okay, so it probably really rolled a 2, but it's level 3, so it got 6, and then we cut that down to 3.0. All right, so now we've specialized our small creature to be a little easier to defeat than the others. Well, quite a bit, really. However, this part of code is literally this base get defensive roll. Okay, so we can actually change this. So we could say, you know what? Give me the super, go to the creature class, and we can call its get defensive roll. And that way, as this evolves over time, maybe we decide to switch to a 15-sided dice or something like that. We don't have to maintain the small animal. It just does whatever the base one does, and it divides it by 2. So let's run this one more time, make sure we're still working. Okay, wizard, tiger, wizard. Could I get a bat, please? Okay, there's a bat. Perfect. Look, bat rolls 3.0. Let's do it one more time. Oh, there's the toad. We just missed it. Okay, total of 1. The toad rolled like an 8, and we cut it in half. So notice how we're using the super to grab the base behavior, but then we're replacing it with our own method so that small creatures have a different style, a different algorithm for their defensive rolls. Last thing is, let's create a dragon, because I know you've been waiting to create a dragon. They're so awesome. I want a black one. All right, so we'll create a dragon, and again, this is going to be a creature. Now, in the small animal in the wizard case, we've said there's no reason to have a specialized init method. Basically, the setup and the data that the wizard and the small animal use is the same as the creature. But the dragon, I'm going to change this. I want the dragon to have a scaliness and an indicator whether it breathes fire or not. So what we're going to do is we're going to define a dunder init, and it's going to have to take all the data, or at least somehow supply the data that the creature is going to need. So name and level. And then I'm going to have a scaliness and a breathes fire. This will be a Boolean to say it does or does not breathe fire. And then the first thing we should do is we should set up the creature feature. So we'll say super.dunder init, name and level. And then we need to assign to the dragon whether or not it has scaliness and whether or not it breathes fire. So we can just say add this parameter here and let PyCharm rock it out for us. Thank you, PyCharm. So now our dragon has different data, different features, and it's probably going to have a different defensive roll that's going to take those into account. So here we can say we'll have the base roll, but our dragon, it's going to have a multiplier. So let me take this chance to show you a slightly different way of doing if statements or conditional tests here. So we'll have fire modifier. Now, if they do not breathe fire, we're just going to have 1.0. We're going to multiply this by the base roll. So if the dragon does not breathe fire, we're going to say 1. But if it does, maybe we'll have a factor of 5 or something. I mean, that's a pretty serious defensive measure that it literally can breathe fire. I could write this. Let me say none, and I'll say if self.breathes fire, fire modifier equals 5. And maybe this could just be 1, okay? But let me put it this way, just an else statement, so it's a little more clear. So else fire modifier equals 1. Now, this bit right here, or using all these lines of code to do this, we can actually write this in a much nicer way. So we'll say fire modifier equals, and I can put this all in one line in this condensed if statement that Python supports. Let me just sketch out the placeholders here. I'll show you how this works. So value if true, say if some test, else value if false. All right. So if we use this, the value if, let's do the test first. So the test is going to be if breathes fire, self breathes fire. So if it does breathe fire, I would like the modifier to be 5. But if it does not breathe fire, I would like the modifier to be 1. Okay, so let me put this like so. All right, so now this will actually let us in one nice little condensed line specify the fire modifier. The other thing is the scaliness factor. This is going to, let's say this is a number between 1 and 100, and it has like a 10% effect on here. So we'll have something like this, scale modifier equals scaliness, self.scaliness divided by 10, right? So if it's 100, you multiply by 10. If it's 1, it actually takes it down a little bit. So then we're going to return base roll times fire modifier times scale modifier. Okay, now let's go back to our program here, and let me just put this back for a minute. That's how it was before we started talking about this dragon. So if I try to run it, it's not going to turn out so well. First of all, it says dragon is not defined right there. That's because I, again, forgot to import it. That's kind of why I like the namespaces. You don't have to keep doing this, but it's all good. So now we have our dragon, but notice PyCharm's already telling us, not so good. But it won't run. It'll say you're missing this parameter of scaliness and breathes fire right there. So let's say that this dragon has a scaliness of 50. Let's say 75, right? That's a pretty serious scaliness, and it does breathe fire. So this dragon is now a much harder thing to fight. All right, so let's look around till we see, let's run away until we see something that is a dragon. Toads, dragon. Okay, dragon at level 50. And what is our level? 75. So we should have a pretty good chance to beat it on the previous algorithm. But this is a very scaly, fire-breathing level 50 dragon. Chances are not good. Let's see what happens. Let's fight it. Whoa. Okay, we rolled 150. It rolled 11,250. I would say we've been defeated. That thing is even worse than the evil wizard now. So let's go back and see how inheritance has helped here. So we have a small animal, which is a toad. And the fact that it's a small animal is it behaves like a creature, but it actually is easier to defeat because it has a different, wimpier get saving or defensive roll method. Creature, this is just a standard creature. The dragon actually is much harder to defeat. It has additional data that it uses to define how it defends when it's attacked. And now it has a scaliness protective layer and it breathes fire. And it takes all that into account during this battle, but the wizard doesn't have to know it's a dragon. It can still treat it like a creature, and yet it behaves differently. Finally, the wizard can also behave like just another creature in the game because it derives from creature. We do this derivation by just defining the creature class, and then we say the wizard is a creature. Here we have an additional method that's not in the creature class called attack. PyCharm, we can collapse those. And then in the small animal, it has a simpler, wimpier defensive role. And notice that PyCharm is showing you this overrides a method in creature, so just be aware of that, right? That's actually pretty awesome. The dragon has its own initialization method because it has to take additional data and do additional setup, but it delegates to the base class for the sort of base class setup. And it has a different defensive role that not just has a different algorithm, but takes into account the fact it has different data, like the scale modifier, which apparently I misspelled. So this just gives you a little taste of object-oriented programming, but the types of applications you can build are seriously powerful, and it's a lot of fun to think about solving problems this way.